This is a video for general chemistry students on how to accurately use a graduated cylinder and get good results when you're measuring volume and how to convert volume measurements. So let's dive right into volume measurements first. And so when we are measuring volume measurements, and a lot of times in chemistry, we're dealing with solutions, things that have been dissolved, chemicals that have been dissolved in water. And so we need to know how to accurately measure them. The tool that we're going to use is called a graduated cylinder. It is a cylinder. As you can see here, here's 4 examples of graduated cylinders, and each one has graduations going up with a different scale. We can add liquid to these to measure with a pretty good precision how much liquid he needs. For example, maybe a lab calls for we need to measure out 15 milliliters of some hydrochloric acid. We would use a graduated cylinder to measure that out. Okay, and so here's a few tips on how to use a graduated cylinder before we dive into the conversion factors. And so the first tip, here's a couple of graduated cylinders, is we want to determine our scale. So if we're looking at a graduated cylinder, and this is our graduated cylinder here, first off we need to determine our scale. So we have 50 most likely milliliters here, we have 60 most likely milliliters there, and so we have 1, 2, 3, 4, 5, and so we're going to have increments of 1. Now this line here is representing, the water level. I'll talk about why it is curved in a moment. But we read the bottom of that. So we're going to read this up as 51, 52, 53, 54, 55, 56, right on 56. So we're going to call this 56 most likely milliliters. I say most likely because I don't see the scale on that. Look to the one on the right here, we have a slightly different scale. So we have a scale, this probably would be a smaller graduated cylinder. We're always going to want to use a smaller graduated cylinder if possible. If we're measuring small amounts, we want to use a small graduated cylinder, larger amounts, large ones, kind of obvious. So we have 3, and then we have 4, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are most likely going to be increments of 0.1. And so we're going to read up here, and so we have right here we have 4, 4.1, 4.2, 4.3. So we're sitting right in between 4.3 and we're sitting in 4.4. And so we're going to make an estimation, and it looks to be, I would say, right about halfway between 4.3 and 4.4. So we're going to go ahead and call that 4.35 milliliters, with that last digit being estimated. Okay, so that's how we look at graduated cylinders, and we have to determine our scale when we step up to them. There's different ones we use in chemistry class that have different scales. A couple other tips and hints for using a graduated cylinder. Make sure you place it flat on a lab bench. Don't hold it in your hand. Make sure you get down and read it at eye level, the water level or the solution level at eye level, and then we're going to want to read the bottom of the meniscus. And the meniscus is this curve that I discussed earlier. This is a meniscus, happens quite often in smaller glass graduated cylinders due to the attraction of water and glass. So you're going to want to read the bottom of it, and that's how we deal with it. Okay, so those are 4 quick tips on reading a graduated cylinder. Let's dive into volume conversions now. Sometimes in chemistry class, what we need to do is be able to interconvert between different units of volume. So let's talk about one of our main conversion factors that we use, and that is going to be, we're going to use in chemistry class, the liter. Oops, that had a little, let's try that again. In chemistry class, we often talk about the liter, which is abbreviated as capital L. In the United States here, we sometimes use the liter for certain measurements of liquid, mostly soda. So we have a 2-liter soda, a 1-liter soda, but that's about it. So we do have a liter, and this is going to be equal to 1,000 milliliters, sometimes called mils, lowercase m, uppercase L. Now, the reason why I give you this equality is it allows us to interconvert between units. Sometimes we're given a unit of milliliters and we want to convert to liters. Other times we're given liters and we want to convert to milliliters for different reasons, and we'll get more into those reasons as we go through this class. So Here's how I attack these problems. So I have a problem here. It says how many milliliters are in 2.75 liters. So if you get into the habit of doing conversions in the way I'm going to show you how to do them, it'll make life much easier for you as we go down the road in chemistry class, because conversions are going to come up over and over and over once we get into atoms and molecules and grams and things like that. Okay, so trust me, do it this way. So first off, in this question, how many milliliters in 2.75 liters, I'm going to identify my known quantity or my given quantity, and that is 2.75 liters. I'm then going to write that down, 2.75 liters, just like this, and I'm going to draw a line under it, and I'm going to draw another line here, making like a little picket fence. Okay. Then I'm going to identify what I'm looking for, my unknown. So it says how many milliliters. So I'm looking for milliliters. So I'm going to go ahead and place milliliters right here on the upper right-hand side of this equality. Now, just to tell you a real quick thing that's going to help us so much, we're always going to put our known value here, and we're always going to put our unknown value there. Okay, and so when I look at this milliliters unit right here, I'm then going to go to my equality up here, and in my equality I have 1,000 milliliters. These two values or this value and this unit are tied together, so I'm going to go ahead and place that right there. So I'm going to put 1,000 in front of milliliters because those two are tied together. Now I've just used up half of my equality, meaning I've used up what was on this side of the equal sign. Now what is on the other side of the equal sign, our 1 liter, we're going to place that as our denominator, 1 liter, just like that. So I took this piece and I brought it down to the bottom. Now what I'm going to do is I'm going to do a unit factor method where I actually cancel out units. So I have the unit of liters here as a numerator. I have the unit of liters here as a denominator, and I'm going to go ahead and cancel those two. Okay, and the way this works is for our mathematical operation, we're going to go ahead and multiply across the top, and then we're going to divide by the bottom. So 2.75 times 1,000 is going to give me 2,750, and the unit that's going to be left over is milliliters. I divide that by 1, I get the same answer, and there is my correct answer for converting between milliliters and liters. I'd like to give you one more quick example. It says how many liters are in 375 milliliters. Once again, we're going to use our equality of 1 liter is equal to 1,000 milliliters. We're going to identify our known quantity. In this case, our known quantity is 375 milliliters. So I'm going to go ahead and write that down right here. I'm going to put a line under it and a line going down. Okay, now I'm going to identify my unknown. My unknown in this case is liters, and so I'm going to go ahead and put liters here. I'm going to look up to my equality and see which side of the equal sign has liters on it, and hopefully you can recognize that liters is right there. I'm going to take that and put it down here, and I have 1 liter. I've now used up half of my equality, so I want to put what's on the other side of the equal sign on the bottom. So I'm going to take 1,000 milliliters. I'm going to drop it down to the bottom right here, just like that. I'm going to double check that my units cancel. I have milliliters as a numerator, milliliters as a denominator, so they cancel. And once again, I'm going to do my mathematical operation. I'm going to multiply across the top. I'm going to divide by the bottom. So 375 times 1 is obviously 375. 375 divided by 1,000 is going to be 0.375, and my unit is liters. And that's how we do conversions between liters and milliliters, milliliters and liters, and use graduated cylinders.